indicate the domain of the function h, and sketch into the graph provided below. Okay, amazing. So we need to get the domain. Domain is the values you can put in your function, right? In x and y in this situation here. So sometimes we have a expression to the function to the variable, but first I want you to start this question alone, okay?
Okay.
And you need to remember some things here have problems in your domain. For example, square root. For example, square root, you cannot put negative values, right? Inside the square root. And logarithm too. You cannot put 0 and negative values inside the logarithm, right?
Yeah.
So you can start to me and you can send me a photo while I do too, okay?
Yeah. Sure.
Hey man, any problem?
Yeah. No, 1 second, and I will send it to you.
Okay, no problem.
How I supposed to do it? Okay. In God we trust.
Let me see. Very interesting. Very interesting. In fact, you are right, because here we need just the absolute value of 1, and here 2. So we have like a square, right, in the graph,
Oh, yeah.
because
So,
they said for us do the graph too. And you said something here, let me see. Yeah, cool. But you need to put this here, okay? Like here is 1 and here -1, okay? But here is points,
yeah.
because we cannot put the value equals 1 equals -1. Here
Okay.
you can. Here you can. Because in square root we don't have problems with 0, but in log we have. Okay?
Yeah.
Okay.
And I have a question.
Yeah.
Can you tell me about this brackets? Like, in which condition which we use? Like,
In which
in a,
conditions?
yeah,
Okay. You said me about this bracket?
yeah, about this bracket. Like, I know that we have different types of brackets in maths, but I don't know how to
Actually, we don't have
why
problems
and
with
when we
brackets,
use
right?
them.
But in this situation is normal you use this bracket here. Okay?
Okay.
Usually.
Yeah.
But it's not necessary. Okay?
Okay.
Okay. So let me see the next question. B, right?
Yeah.
I need download this, but I think it's not necessary now. Just this. Calculate the gradient vector. Okay. Gradient vector is easy because we have a equation. right? Is the partial
Yeah.
derivatives. So if you do this for me, I appreciate. Okay? Because I already
Mm.
did. Okay? So when
Yeah.
you do, just tell me and send me a photo.
What?
Sorry?
Oh, no. It's just I realized I applied chain rule and I am very happy about it that I get how to make it correctly.
But you can send me, okay?
Yeah, sure. I will send you in like just in 1 minute. I need to finish. And I
Okay,
will
no
send it.
problem. Let me see. You did the
Yeah,
derivatives. Okay.
and I'm a little bit lost what I supposed to do. Like,
Yeah, you need do the same thing I did last class. Last class,
yeah,
I showed to you my strategy to do derivatives by chain rule, right?
yeah,
So I think that's very cool. You need to use
yeah. I applied
um,
chain rule.
if you feel lost during the derivation. Let me see. Okay. So okay. Right. But that is a constant in x derivation, right?
Yeah,
So you need multiply all these things by this. But okay, let me
yeah.
see
That
the
I write. I wrote it in the next equation there.
okay.
Yeah, and
Yeah, but you don't show to me the right answer. Okay. What you
yeah,
did
because I
here is right, but you need put more things here to do the right answer.
yeah. That's I. Can you tell me how to?
Okay.
What should I put?
First, you need to understand you have a partial derivative. So this is constant. Okay. So in
Yeah,
x, this is constant. Okay. So if you are doing the x derivative, you need do only the derivative of this term here in square root. You did this.
yeah,
So we can do what you did. 1/2 minus 1/2. And now the derivative of the inside part. But now you need multiply by the constant term, okay?
yeah,
Because this is like a number, right? Like the number 2, for example,
yeah,
when we are doing the derivative in x, okay?
yeah,
So it's just like that. You can simplify a little bit. And okay, this is the x derivative. Okay, very easy. If you do the chain rule. But this chain rule is very easy, it's very
Yeah.
common, okay? And
Yeah.
now, and here you are right too. That in y derivative, you are right. In the another archive,
Yeah.
just a second. Here, you did the derivative, but we have a log. So log is not the natural logarithm, right? I
Yeah.
suppose, because this depends of your teacher. If your teacher say this is the natural logarithm, okay, but in my symbology, this is not the natural logarithm, so the answer is not this, okay?
Oh,
Because if you pay attention in the table of derivatives, I will send to you now, just a second. If you open the table, this archive I sent to you, we have, for example, if you pay attention, these two derivatives, okay? This derivative is the natural logarithm, right? The derivative of this is easier, okay? It's just
okay.
what you did, but we have in that question this situation, right? So I don't
Oh,
know what symbology your teacher are using, but I suppose in that situation the basis of this logarithm is 10, right?
oh,
I
okay. Yeah.
think so. But some teachers using another symbology. Some teachers using log without basis when the basis is the number e. Okay, so I don't
Oh,
know.
okay.
I don't know.
Okay. So natural logarithm we write as ln, correct?
Yeah,
And this logarithm we're supposed to apply another formula because it is not a natural.
it's a similar formula. If you pay attention, it's the same thing in the natural logarithm, but you need to multiply by this situation here, the log, the letter a. But I don't know because this depends of your teacher, okay? But we can consider
Okay.
it this situation, this, we can consider this situation, okay? And
Okay.
in this situation, your answer are right, but some things is a little strange here because okay, you need to derivate the thing here and divide it by this thing again. So all right. Yeah, you are right. But again, you need multiply by the x part. Okay,
Yeah. Yeah.
just like that. So just like that, very easy.
Yeah. Yeah.
And now you have the gradient, but the gradient in this situation, you need to put some values, right? um,
Mhm.
0 by x and minus 1.5 by y. But this is very easy, okay? You know how put the values in your derivative, okay? Very easy. You don't need to do this now, okay? Let's go to the next question. If you have some
Yeah.
doubts, just tell me, okay?
Yeah. Sure.
Oh, we have more things in this question here. Let me see. Using Lagrange multipliers method, determine the extrema of f subject to the constraint. Okay, this is very cool because we already did the derivatives. The Lagrange multiplier is a method to obtain critical points, max or minimum points. Okay, but it's very easy. We have a formula to do this equation. is something like x, y, and lambda, the Greek letter. You repeat the equation, but we have the constraint equation multiply, oh my God, multiply 2 minus lambda in this equation here. Okay?
Okay.
Oh my God. Problems. Technical problems here. But okay.
Yeah.
Okay. So to do this, you need multiply, sorry, you need derivate this, okay? But you already did the derivations without this term. But
Yeah.
if you derivate this term, you'll be a similar thing you already did. For example, in X, we get this situation here. If I'm right, if you simplify some things, we get this, okay? My God.
Yeah.
But now we have the derivation this term, but this term is linear, it's very easy to derivate. So we have minus lambda y, okay?
Yeah.
Similar to the derivation y. Is the thing what you already did. Okay. And we have a third derivation and lambda, because lambda is a new variable in this problem. The lambda control the constraint of this problem, okay? The limits.
Yeah.
Amazing. Why I put equals 0, equals 0, equals 0 here? Because we need the critical points. The critical points in calculus, we get equalize the derivation to 0, okay?
Okay.
So you can now do some math in these terms to get the values of x and y, the critical values of x and y in this situation. Okay, it's very easy if you isolate this term here and this term here, and you can do substitutions. Okay, or
Okay.
divide these equations. It's easy, okay, but you need to do some algebra here. But it's very easy because we have a lot of simplifications. Okay?
Yeah.
So I want you try something. If you don't get some answer, you can send me. Okay?
Okay.
But I suppose in your graduation you can use graphical calculators in your tests, right? Can you use graphical calculators in your
As I
tests?
know, we can't use any calculators on our tests.
Oh my God, this is very strange because this problem here is very useful. You use a graphical calculators because we will get a hard equation, a transcendental equation. Transcendental equation, we cannot isolate the variable. So this is a very problem here if you cannot using the graphical calculator. Okay, but you
That's
can
true.
try. You can try. Okay.
Yeah.
If you get something, send me. I need to go to the bathroom, so
Yeah. Sure.
I come back in 1 minute or
Yeah.
two.
Yeah. Sure.
I am back, okay? Any
Yeah.
doubt, just tell me.
Sure. Teacher?
Hi.
Yeah. No, I don't get how to solve it.
Okay.
Yeah, can you please show me?
This is very, very hard. Okay, this is
Yeah, it
very,
is.
very hard because we have two hard equations with problems like log and like square root. This is very hard, but we have a new variable to help us, is the lambda. Okay,
Okay.
so we can start our strategy using the lambda. For example, I can copy this and I will erase this and put the equal sign here, and I will do the same thing here.
Oh,
Uh, so we have two equations similar now. And if
oh,
we divided these two equations, the lambda will cut. Okay,
yeah.
so if we do some simplifications, we will get this equation here. This is very easy to obtain, but
Oh,
is not very useful for a while. Okay,
mm,
because we have two variables. No. We have one variable because I already substitute the value of y. Okay,
oh, okay.
because we know something about y. We know y is 1 over x, right?
Oh, yeah.
Yeah. So very cool. We get this, but this yet is a problem to us because we can cut here, okay, but we have a transcendental equation. I already did this. We have this transcendental equation here. What is a transcendental equation? Is an equation we cannot isolate the value, the variable, okay? If you can use a graphical calculator, you can put this in your calculator, and this will be some magic, and will do the value for you. The calculator will do a numerical calculus. Okay, for example, here we have a x square, here we have a log, here we have the line -2. So we have, for example, a point. We take these two things. This will be the answer. But we cannot do this isolate x because it's impossible isolate x. Okay.
Yeah.
So we don't have a solution, an analytical solution, but we have a numerical solution. I guarantee for you the solution is this answer. Okay.
Yeah.
But you only can take this value using a graphically calculator. Okay. So this is very sad for us. If x is this value, y is this value. These values. Okay.
Okay.
So we have these two values using the calculator, but I suppose you can bring until here. Okay. You can
Okay.
get this equation doing algebra. Okay, because it's very easy to manipulate the equations for it. Okay, this is very important when you are working in calculus 2 in this critical point situation. Okay, it's very important to you do the manipulation. Okay.
Yeah.
You need to train in this. It's very important. So, okay, this is the answers. You need to know if these values is a maxima or a minima critical point. Okay, and what we can do for know this? You just need to put these values, these 4 points, because we have 4 points here, in the equation, in this equation here, and you need to note if you have another point is bigger or is what's the opposite of bigger in English? What is the opposite of bigger in English?
Smaller.
My memory, my vocabulary is the worst. But okay, if you have a point is bigger, then the answer of this one of these 4 points here. For example, we can test 1 point. The point 1, 24, and 0, 8, 1, right? And what you will do, we will put these values here, and you will get a value to 8, okay? So you can test another value, and you can verify if this another value is bigger or smaller. So if it's bigger, your point is not a maxima point, it's a smaller point, okay? It's very easy. It's just test the values. We don't have a more hardest method. This is the unique method, okay? For example, in Calculus 1, we have that method using the second derivative. But now we are doing the Lagrangian thing, right? Lagrangian multiplier. So in Lagrangian multiplier, we cannot use the Hessian matrix. Now, sometimes in Calculus 2, we using the Hessian matrix. Hessian matrix is a matrix with the second derivatives, okay? But when we are using the Lagrangian multipliers, we cannot. You don't need to use that, okay? It's just test the points. It's more easier, okay?
Okay.
So you can do this after our class. We have another 2 things here to do. Let me see. Note of the extrema point you obtain C is absolute maximum. You need to use that thing I will say to you. 5. If I is a square matrix, satisfy A square equals A, show that. My God, this is another question. This is a matrix question. You need to do. You need to do this 5 question. Do you need to do this? Do you need to answer this thing? Because this is very different of the another questions. But I can do for you, okay?
Yeah.
Okay.
I want to do.
You need, okay. What you can do in this situation? Bem, we can using a cool idea. For example, if this is true, we have this too.
Okay.
So you can isolate the matrix A. So we will have this. This is more cool. This is more easy to work. Okay. Because if you have this, we have 2 cases to analyze. For example, if the matrix A is not invertible, meaning the determinant of A equals 0, okay?
Yeah.
This is a property of matrix. If the matrix is not invertible, meaning determinant equals 0, okay? So this is our first case, case 1. Matrix A is non-invertible, meaning that determinant of A equals 0. But we have another case, okay? Because this equation is equal to 0. So this can be 0 or this, right?
Yeah.
Amazing. So case 2, matrix A minus identity is no invertible, which implies that A minus 1 equals 0. Okay. But if this is true, so this thing might have a non-trivial kernel. Okay?
Okay.
So this is very important to us. Now we can assume, to start our considerations, we can assume A is invertible. Okay?
Okay.
If A is invertible, we have a situation very interesting, because we can take the equation, the original equation, and we can multiply these two sides by this thing. Okay? If it is invertible, our supposition. If A is invertible. My letter is the worst. My calligraphy. Okay. So if you do this, you will take this thing here. Thus, if A is invertible, it must be the identity matrix A. Sorry. No, A. I don't know. A, B, C, D, E, F, G, I. B, I love you. Right. Okay. So if the A is invertible, so we have these situations to put here to show your teacher. If A square equals A, like the question, we have some situations. A is not invertible. That A equals 0, or, this is important, A equals Y. Okay? Because we do this math considering the second case, when this thing is invertible. But this thing is not invertible, but A need to be invertible, because we need 0 in our multiplication, right? So I consider this thing not invertible, but this is necessarily invertible. So if it is not necessarily invertible, we can take the equation, multiply by the inverse, because this exists, and we will have this thing. Okay?
Okay.
So we have this answer here, these two possibilities to answer our question. Okay?
Okay.
This problem is more algebra than calculus. Okay?
Yeah.
Amazing. Man, I suppose we don't have more time to do another question. So we can do our class tomorrow, okay? More questions tomorrow. Okay, okay. Amazing. So until tomorrow, bye-bye.
Yes, thank you very much. Okay. It's really great to understand something.
Cool. Bye-bye.